We're going to talk about solving quadratic equations. We're going to do this lots of different ways. So hopefully each one of these things, maybe if you're just coming back to look at the video later, I can put the stuff down on it. So the first way is going to be graphing. And how do I solve a quadratic equation by graphing? So let's say I have this equation, x squared plus 7x minus 6 equals 0. And when we say to solve this, we're looking for the two places where this crosses the x-axis. So one of the things that we would do, if we're going to do it by graphing, is just take our handy-dandy calculator out here, go ahead into your y equals, and clear out anything that you have in here. Make sure again that your plots are all empty. I'm going to go ahead and zoom in on this now and focus it up so that you guys can see that nice and clear. And then I'm going to go ahead and put in that equation. So x squared plus 7x minus 6. X squared plus 7x minus 6. And then I'm going to hit zoom 6. And the reason zoom 6 will definitely work for this is because it's where it crosses the x-axis. And that it definitely will happen between negative 10 and 10. So I hit zoom 6 and you can see there's my parabola. And those are my two solutions, the two places where it crosses the x-axis right there. Now I can do a couple different things. I can do second trace and number 2. Find the zeros, and this will ask me to find a left bound. So that means if I'm going to try and find this 0, I just need to put my cursor someplace to the left side of it. So I can just hit enter where my cursor's at, that's to the left side of it. And then I simply move my cursor up above it, so now that cursor's to the right side of where it crosses the x-axis. I hit enter. It asks me if I want to guess, but I really don't. So I'm just going to hit enter, and I can see that one of my solutions is 0.77. Okay, so I go on my thing and I get x equals 0.77. I can go ahead and do the other one the exact same way. Second trace, number 2 is a 0. I can, if I don't want to move my cursor, I can also just type in a number that's to the left of it. So like I can type in -9 and hit enter, and it'll put that line up there. And then for right bound, I can either move my cursor or I can type in another number like -6. Enter, and it'll show you, it'll find any place that it crosses the x-axis between -6 and -9. I hit enter, and I can see that it hits at -7.77. So x equals 0.77 and -7.77. Those are the two solutions, and we would know also if we took these two numbers, and they're rounded, and plugged them back into here, it would equal 0. So let me show you that real quick. I'm going to go to my home screen in -7.77. I'm going to store that in x. Remember, this is just an approximate for it. It's not exact, so it's going to be close to 0, but it won't be 0. So I got x squared plus 7x minus 6. Hit enter, and you can see it's really close to 0. The only difference is it's rounded a little bit. Okay. And clear that all out. So that's one of the ways that we can solve a quadratic equation. We can do that by way of something called graphing. Another one that we're going to do is we're going to solve the equation just algebraically. So let's say that I have the ability to do this. I don't have a linear term in with this. So I have something like this, 4x squared minus 7 equals 18. So if I want to go ahead and solve this, and I don't have an x term in there, I can just use basic algebra skills, right? I can't do basic algebra on this one. There's other things that we're going to get to that we'd have to do. So I can add 7 and add 7, and then I get 4x squared equals 25. Divide by 4, divide by 4, I get x squared equals 25 fourths, and what is that, 6.25? 6.25. Yep. And then to get rid of a square, you guys know we have to square root it, and then x equals, and this is where we got to be careful on it, it equals plus or minus whatever the square root of 6.25 is. And I'm going to do that on my calculator and get an approximation. Second square root 6.25. Oh, duh, 2.5. I should have known that. So positive 2.5 and negative 2.5. Now, the nice thing about this is, if I was to take this and put this into my graphing calculator, it would cross at 2.5 and at negative 2.5. So you're not going to get different answers doing it different ways. You're just going to learn different stuff. So here we go. The next one's going to be a process that we call completing the square. In other words, how do we get something into a perfect square? And I know that you guys have done this before, because I know that I've asked you to do it before in data. Complete the square. And we're going to have to do it in this class a lot. You should have done it in Algebra 1. You also should have done it in Data A in the conic section and in the quadratic section. So here we go. So let's say we got this x squared plus 6x minus, let's go 10. X squared plus 6x minus 10 equals 0. Now, I know because this has a y-intercept that's negative and this opens up, that there's got to be some solutions where it's possible that we get imaginary solutions or solutions where it doesn't actually touch. Example, let's say I had a parabola looks like this. It never equals 0. Okay, that's not this one, but let's say I had a parabola that was up here like that. So we're gonna talk about this process called completing the square now. So completing the square, basically you do this, okay? You're going to take x squared plus 6x. You're going to take all the things that have the letters in them. You put them on one side of the equation. You're going to put the numbers on the other side. So when I move the negative 10 over, I get positive 10. I'm going to look at my linear term right here, and I'm going to take half of that linear term. Half of that linear term is 3. I'm going to put it in a little square box over here on the side. And then anything in the square box gets squared. Okay, and that's what's called the process of completing the square. And 3 squared is 9. So I'm going to add 9 here, and I'm going to add 9 over here on the other side of the equation. I have now made this quadratic a perfect square, which means it's factorable into two things that are identical. And those two things happen to be x plus 3 and x plus 3, which we could rewrite as x plus 3 squared. Now, I don't have to be able to look at this and try and factor it. I just know that it's going to be this, because it's always going to be x and whatever's in your box. That's a positive 3, so that's a positive 3. On the other side, we get 19. Now that I have this entire thing that's squared, which means I can square root it. And if I square root one side, I can square root the other side. So then I get x plus 3 equals plus or minus the square root of 19, which you can change to a decimal if you'd like, but I'm not going to do it right now. Subtract 3 from both sides. So now I know x equals negative 3 plus the square root of 19 and negative 3 minus the square root of 19. Those are my two possible solutions. I'm going to go ahead and put those into my calculator just so you have approximations right now so you can see those. So negative 3 plus the square root of 19. I'm going to get 1.358. And then negative 3 minus the square root of 19, negative 3 minus the square root of 19, and I get negative 7.358. Okay, so those are the two things that I get from a process called completing the square. Now notice I got both of these without the use, technically I got both of these without the use of the calculator. I got the approximations by putting them into the calculator. But I'm going to show you right now on this that all the stuff that we did above, we could still do. So if I go to y equals, and I go ahead and put this in, x squared plus 6x minus 10. So x squared plus 6x minus 10, enter, and then hit graph. I'm going to show you another way to get the zeros right here, and that's simply by going to y equals, plugging in 0, and finding out where the parabola intersects the horizontal line at 0. So now I can hit graph, and you can see I got a blue, I got a red. Focus that in a little bit so you can see it. Actually, I'm going to blow it all the way up so it's big on the screen for you. And now I'm going to go second trace, number 5 intersection, enter, enter, enter. And you can see one of those solutions right there is my 1.358. You can see that. And then second trace, number 5 intersection. Remember, move your cursor closer to the other point because it can't find the other one unless Well, it's going to find whichever one's the closest to your cursor when you do it. And 3 enters again, 1, 2, 3. And there's my negative 7.3588. Good deal. So you can see that graphically is what algebraically. The big difference is that this didn't require technology. And that's one of the things that we want to really practice on in this class, is being able to do stuff without it. Okay, number 4, we're going to use the quadratic formula. And the quadratic formula, most of you remember, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So yeah, well, pop goes the weasel right there. That is, that's the equation that we're going to use. Okay, so let's go ahead and use a nice easy one. And the reason why I'm going to say it's easy, watch, I'm going to do x squared plus 7x plus 10 equals 0. And I'm going to throw it in here as I know that this one's going to be a good solution because, and again, it doesn't require the quadratic formula. I know that it's x plus 2 and x plus 5 if I factored it, because we've worked on our factoring, which means I know my solutions are x is equal to negative 2 and negative 5. And my goal is to be able to show how the quadratic formula gets me negative 2 and negative 5 right now. Quadratic formula will work every single time, and it will be easier sometimes than this whole completing the square process or some of the other ones. But factoring like this, that was really quick, right? So here we go. So this in front of your x is your a, in front of your x squared is your a, in front of your x is your b, and the constant number right there is a c, and it's only a, b, and c if all of these are on the same side of the equal sign, and you have a 0 on the opposite side. So one more time. Whatever's in front of your x squared is your a, whatever's in front of your x is your b, and whatever is your constant term is your c, assuming they're all on one side of the equal sign and the other side of the equal sign is 0. So negative b becomes negative 7 plus or minus the square root of b squared, which is 49, minus 4 times 1 times 10, all over 2 times 1. You can see where all those numbers come from the a's, b's, and c's from our different things. In fact, I'll even write them down there for you. A is equal to 1, b is equal to 7, and c is equal to 10. For those of you who are really clever, you can probably even write a little program in the basic of your calculator to be able to solve it. You go ahead and do that. You can use it on the test. I'm good with that. Like that. So here we go. So that's negative 7 plus or minus. Okay, so 49 minus 40. 49 minus 40 is 9. Square root of 9 is 3 all over 2. So then I have negative 7 plus 3 over 2, and I have negative 7 minus 3 over 2. And amazingly, watch what just happens. Negative 7 plus 3 is negative 4 over 2 is negative 2. Look at that. That's one of the ones I said we're going to have. Negative 7 minus 3 is negative 10. Negative 10 divided by 2 is negative 5. And look at that. That is the other one I said we were going to have. But that is using the quadratic formula. Okay? So hopefully so far this has been pretty good for you guys. Just remember again, if you're going to solve using the quadratic formula, you got to move it all to one side of the equation, all to one side of the equation. So here we go. What happens when I get bigger than a quadratic? What happens when I get maybe a cubic equation? I get a big old honking thing. So let's say that I have x cubed minus 5x squared minus 206x plus 142. Okay, I just made all that crap up. I have no idea. But I'm going to set it equal to 0. I'm going to say, hey, what are the solutions to this? Well, guess what? I cannot use completing the square because it's a cubic. I cannot use, I can't factor that. That looks really scary, so I can't factor it. I can't use the quadratic formula because that's only for quadratics. So it looks like my only thing that I can do is A, guess and check, which would be brutal. Don't want to do that. Or I can use my graphing calculator. So let's go ahead and put it into here. Go ahead and turn it on. Go to your y equals clear, and I get x cubed minus 5x squared minus 206x plus 142. Oh, do you see what just happened? Nope, you probably did. Sorry, my calculator's over there. This up here again, and focus it. Try that focus one more time. Okay, you can see when I typed it, everything went into the exponent spot, and I don't want that. So I got x cubed, then I got to hit the right arrow on this calculator, minus 5x squared minus 206x, and then that's plus 142, plus 142. And I'm going to go ahead and hit graph. And you can see that on this calculator, it looks like there's only one possible solution. That there might be some other stuff going on in here, but I can't really see it right now. I'm going to double check. I'm going to move my x's wider, negative 20 and 20, and see if anything else shows up. Oh, look at that. Look at that. There's actually 3 solutions, okay? So we got to be really careful with this on the graphing calculator, that if we do, make that darker for you. If we do think, because there's a cubic, that there could be 3 solutions, sometimes I have to expand my window to see them. Now you're like, this looks like 3 straight lines, but I'm going to show you about it going up and down on the y. So on the window, I'm going to have my y go all the way down to negative, like say 300, and all the way up to 300. And then you can see that there's a little bit more curvature. Okay, so let's make this negative 600 and 600. Still not far enough, but I'm getting closer. You can kind of see the top of that curve. So let's go a little bit crazier. Let's go negative 1200 and 1200 in graph. And now you can see, oh, I still didn't get far enough, but it's looking a lot more like a cubic. Okay, but again, big deal is I only need these 3 things right up here where they cross the x-axis where they're equal to 0. So again, your choice. Let me go back to zoom 6, which doesn't show it. Spread these out at negative 20 and 20. And I'm going to go ahead and solve it by intersection. So I'm going to go to my y equals. I'm going to put 0 in for the other equation. I'm going to hit graph. And then I can just go across second trace, number 5 intersection, enter, enter, enter. And you can see here's one of your solutions. Do the same thing for the other ones, and you will be all set. Now again, in these videos, I'm not doing a whole lot of giving you problems to practice. And the reason is because all the practice problems are actually in the homework. So that's where you should be able to do it. And I'm giving you a couple, I think 3 different guesses, 3 different chances in the homework, in order to be able to get those right. So just make sure that you take the time to practice those ones. Okay, let's see other things that we need to be able to find in this unit. There's going to be a couple of these ones too. So besides quadratics, another thing that we have that looks kind of like that is absolute values. So this is, I think it's number 5. Oh, this was 5. This was cubics. And then we'll call this 6 absolute values. So if I'm solving an absolute value equation, I'll have something like this. Absolute value of 2x minus 5 plus 7 equals 8. Okay? So just so we're kind of clear, absolute value equations like this look like these. So basically it's an entirely straight line that at some point everything that was going to be in the negatives changes to become the positive, and that's why it looks like a V. Okay? So this one's been tweaked a little bit. It's been shifted a little bit, both vertically and horizontally, and we want it to equal 8, which is some point right up there. Okay? So that's what it's going to be. There's going to be 2 solutions, and I'm going to show you the algebraic way first, and I'm going to show you the graphically. Okay? So algebraically, I can't deal with an absolute value until I get it isolated, so I have to move this 7 over. just like that. So now I have 2x minus 5, absolute values equals 1. So if I cover this up for just a second, I'm going to ask you what could be under my finger in order to make this equation true. And the answer is 1 could be under my finger, or negative 1 could be under my finger, because the absolute value of both 1 and negative 1 equals 1. So that's what I got to do. I have to write 2x minus 5 equals 1, and I have to write 2x minus 5 equals negative 1, because either one of those two things will work to make this true. So here we go. I add 5 to the other side. I get 2x equals 6 and x equals 3. And over here, I add 5 to the other side. I get 2x equals 4, and then x equals 2 when I'm dividing by it. So my two solutions are 3 and 2. And now I'm going to show you on the graphing calculator how to get both 3 and 2. So again, zooming in right here. And go to my y equals, clear out my old stuff, and you're like, wait, is there really such things as absolute values that we can graph? And the answer is yes. You're going to hit your math key. Math is right below your alpha key. So you hit math. You're going to go over one column to the right under num, and this first thing says ABS. And on the old calculator, it'll actually say ABS, and it'll give you parentheses. On the newer calculator, it actually shows the absolute value signs. So I'm going to go ahead and put in 2x minus 5 right there. 2x minus 5. And then I'm going to put plus 7 on the outside of it. And we want it to equal 8. So I'm going to put 8 on y2. Good deal? I always like to put the original equation in when I'm doing this. And then I'm going to go ahead and hit zoom 6. And you can see there's the v that I was talking about. There's the 8 that I was talking about. That horizontal line. And it touches two places. Let me show you here on the y max. It blown up a little bit bigger. So there's my absolute value. There's the two places that it hits. All I need to do is find second trace intersection. Now one of the things I'm going to do, I'm going to show you something new all the times on these calculators. We're going to go ahead and do zoom. And first one says zoom box. I like zoom box. So I'm going to hit 1 on zoom box. And I'm going to move my cursor over here by where I want to zoom in on. Probably about right there, a little bit up and left of the things. I'm going to hit enter. I'm going to move my cursor to the right. I'm going to hit enter. Oops, sorry. I need to go one more thing on that. Back to graph. Sorry, zoom, number 1, box. I hit enter. I don't need to do it twice. I just need to do it once. So I'm going to go down arrow and then over arrow. And you see I put a little box around this area. And I'm going to hit enter. And what it does is it blows it up just on that location. Isn't that nice? So if you need to highlight a certain part of your graph, that's a great way to be able to do it. Now I can do second trace, number 5 intersection, enter, enter, enter. And there's one of my solutions. You can see that. There's 3, and then second trace, number 5 intersection. Moving my cursor over this way, just like this. Enter, enter, enter. And there's 2. And those are my two things that I got. Do it just like that. Awesome. So those are solving some absolute value wise, solving some of them graphically, and next one, last one. I know this video is getting kind of long, but there's a lot of stuff in this. We might take 2 days on this. Let's do story problem. Ooh. So we're going to put some applications together in one of these problems and see if we can do it. And I'm probably going to use my graphing calculator on this one. And okay, good deal. So here's the deal. What I've got is I've got a square with a semicircle on top of it. And I want to know if the area of the whole thing, if the area equals 700 cubic inches, what is the perimeter? You're like, what the heck? Can I do all that math? And the answer is, I hope you can. So the area of this whole thing is 700 cubic inches, and I want to know what the perimeter is. So the perimeter is this length plus this length plus this length plus half the way around a circle, right? Half the circumference. Good deal? So what I have to do is I have to be able to write a true equation. Well, I know that the area of this square, because it's a square, and I said that up front, the area of that square is x squared, because it's length times width, or side times side. Good deal? Now, if this is a semicircle, then its radius must be 0.5x. Does that make sense? So if the area of a circle, a whole circle, is pi r squared, then half of this circle should be half of pi r squared. Sweet. So I'm going to put that in there. Plus pi times the radius, which is 0.5x squared over 2. And this area plus this area is supposed to equal 700. Oh, I'm so sorry. I looked at my computer, realized that that was kind of blurry. I know you're probably talking to me in the video. So it looks like that. Okay? So one more time. I had a semicircle on top of a square. I knew that the area was 700 cubic inches. Sorry, 700 square inches. Some of you are probably laughing at me like that. Again, this is late at night right now, trying to do these ones while dealing with all kinds of other stuff at home. So the area is 700 square inches. Trying to find out the perimeter. This is an equation that I can solve because it's a quadratic. However, this is scary. I can't factor that thing. I can't use algebra with that thing. Well, yeah, I probably could use algebra. It won't be that hard. But I'm going to say graphically is probably the best way to go about doing it. So let's go ahead and grab our handy dandy little calculator. And let's go ahead and put this in and see what we get. Okay. So go to my y equals. Clear out both of these, and I'm going to put in x squared plus parentheses, because I have an entire numerator right here that needs to be divided by 2. Pi, which is second function in your exponent key, your up arrow, the little triangle or angle thing, times parentheses 0.5x, close parentheses, because only that part gets squared, not the pi. The pi doesn't get squared. But everything needs to be divided by 2 in this, so divided by 2. You got to be really careful about how you put stuff into the calculator, making sure that it's all right. Down in y2, we have 700. So again, the top is a quadratic parabola that opens up, and then 700 is a vertical line. So I'm going to go right here on my Zoom 6. And I know that's not going to give me anything, because I need to know where this thing hits 700, and right now it only equals 10. So I'm going to go to my window, I'm going to go to my Y max, I'm going to make that 900. And it could be that I need to go a little bit wider to be able to see it. So I'm going to go out to negative 15 into 15. I think that'll be wide enough. We'll see. Nope, not wide enough. So window, let's go out to negative 30 and 30. And graph. So now I'm going to get these two things. Second trace, number 5, intersection, enter. And that gives me this solution right here, right? Which on my calculator shows 22.419. And I'm going to go ahead and say that x equals 22.42. I rounded a little bit. It's going to be okay. It's going to be okay. For you guys to round a little bit. Okay, so, but that's not my answer to my question. My answer is I need to know the perimeter. So I know that I have this x plus this x plus this x. So 3 x's, yes, plus the circumference of a circle is 2 pi r, but I only want half of that circle. So if I divide that by 2, technically I just have pi r, right? So plus pi times my radius, which was 0.5x. So that's what I need to be able to do, and add all those up. So here's how I would do it on my calculator again. We are so close to being done with this video. Hopefully you're taking great notes on this. I'm going to go ahead and go to my home screen. I'm going to put in that 22.42. I'm going to store it in X. Hit enter. And I could have put the 0.419 and written all this stuff down. I'm okay with it right now. And then I'm going to put in this 3x plus pi times 0.5x. So 3x plus pi times 0.5x. And I hit enter, and you can see that the perimeter of my entire shape is 102.47, 102.47. And yes, that problem is kind of big. It's got a lot of stuff to it, but I believe in you. Again, this has probably been the section that's been the most difficult so far, at least until we get to tomorrow's stuff. Hopefully this was beneficial to you. We will talk to you later.